In this video, we're going to look at an exam question that involves drag and air resistance. So pause the video now and try all parts of this question. Part A is a classic unit problem. Show that the units are or could be this. So we need to show a unit for force. So we probably want to work in base units here. So I always think force is mass times acceleration, which is kilogram meter per second squared. We need to work out our units for area, which is obviously meters squared, and our units for velocity squared, which is meters per second all squared, which is meters squared seconds to the minus 1. So K is obviously force over area times velocity squared, rearranging it. Now we can plug in our units that we've just worked out and see what we end up with. So we're going to have our second to the minus 2 cancels with second. So we're going to end up with just seconds to the minus 1. We've got meter over meter to the 4, which is meter to the minus 3. And then we've got kilograms here. So what have I made a mistake? Obviously, that's not correct. Here we go. Here it should be meters squared, seconds to the minus 2. So, of course, that should be seconds to the minus 2. So they cancel. And, of course, this isn't here. And we get what we want. Part B. On figure 6.1, draw an arrow to show the direction of travel of the ball in situation A. So what do the arrows represent? W is obviously the weight and D is the drag. Drag is a form of like air resistance, or in this case it is air resistance, it could be water resistance, and it always acts directly opposite to the motion. So the arrow should be directly opposite to the motion. So here the direction of travel would obviously be this way, and here the direction of travel would be this way. Part II, is the ball moving at terminal velocity in B? And it says the magnitude and weight of the drag are the same. So that might lead you to think that it is travelling at a terminal velocity because the magnitude of the drag and the weight are the same. But this can't be the case, right? Because think about it, what's the resultant force? It's somewhere here. So there is a resultant force. So it cannot be at its terminal velocity. The only way it could be at terminal velocity is if the drag and weight are in exactly opposite directions, which is actually a perfect alternative answer that you could write down. And then part II, we've sort of answered this already. It's travelling vertically upwards. And we know that because the drag has to be opposite to the direction of motion. And then it says explain the motion. So what is going to be happening? It's going to be slowing down, or we could say it's going to be accelerating down because, and this is the explain part, there is a resultant force acting down. How do we know that? Because obviously the weight and the drag are both acting downwards. The final part of the question is here. 4-mark question. Pause the video now and try this question. So what are the 4 marking points? So at the start, the acceleration is 9.8 meters per second squared, which is G. All right, because as soon as it's dropped, we have the weight acting on it with no other forces, so accelerate with G. Then what happens as speed increases, so as it accelerates, air resistance increases, or you could say drag increases. So therefore, the net force or the resultant force decreases, because now we're in a case where there is weight, but there is a little bit of air resistance, but they're not the same. And therefore, what happens? Well, we know that the resultant or the net force is mass times its acceleration. So if the net force decreases, then the acceleration also decreases. So that's enough, and it says very clearly that it does not reach terminal velocity. If it said it does reach terminal velocity, then you'd probably add another bullet point or two, and you'd say that as it gets faster and faster, eventually it reaches a point where drag equals weight, and therefore there is no resultant force. So it's a terminal velocity. But obviously that was not asked in this question.